Hi, this is Mr. Anderson, and we're going to go over these practice problems you just tried. Make sure you're doing okay. So our first problem is oxygen. Oxygen, as we look at the atom, has 8 protons. We know because that's what the atomic number tells us. Protons equal electrons here, so that's also 8. To find our neutrons, we take our atomic mass of 16. We minus it by the atomic number of 8. And that gives us 8 neutrons. So I can put that in our neutron box. And when we fill out our atom, we know that there are 8 protons in the nucleus. We know that there are 8 neutrons in the nucleus. And then we can drag down one of these electrons. And our first orbital, remember, it fills at 2 electrons. 8 minus 2 gives us 6. And the next orbital can hold up to 8. So all 6 of my electrons will fit here. Okay. Check your work. Moving on. Fluorine. Fluorine has 9 protons, 9 electrons, and our mass was 18.9. which rounds to 19, minus 9 gives us 10 neutrons. Put that in our neutron box. And our protons, we know are 9. And we know our neutrons are 10. And we'll bring an electron box over here, and we know that there were 2 electrons in the first orbital. And the second orbital can hold up to 8. 9 minus 2 gives us 7, so all 7 will fit here. All right, and there's fluorine. So let's move on. Sodium. Notice that even though this is sodium, its Latin name starts with an N, so that's why we have Na. And the atomic number shows us that there are 11 protons, 11 electrons. Our mass is 22.9, which rounds to 23, subtracted by 11, and that gives us 12 neutrons. So put that in our nucleus. We have 11. All right, let's go back over here for a second. Our neutrons, I forgot to put them in our box. There we go. So we have 12 neutrons. Get that in our atom. Adjust this a bit so our positive sign fits. There we go. Now let's bring our neutrons down here. Now this time we know that there are always, this first orbital fills up at 2 electrons, and then orbitals or electrons go out to the second orbital. 11 minus 2 gives us 9, and all the electrons will not fit here. So this orbital fills up at 8, and then we're going to put another electron box down here. And that leaves 1 left. All right, now let's check our work quickly. Remember, we can do that by looking at the periodic table. We're going to find sodium. Here it is in this first column. And if you look, there is a Roman numeral 1, which tells us that we should have 1 valence electron. Remember that valence electrons are the one on the most outer orbital. And so that checks out. Next up is neon. And neon has 10 protons, 10 electrons. Our atomic mass is 20 minus 10 gives us 10 neutrons. All right, put those in our nucleus, and we have 10 protons. And then we have 10 neutrons. And bring our electrons down. We know the first energy level will fill at 2. And that leaves us with 8 left. So we know that fills with 8 electrons. And again, to check ourselves, we can look at our periodic table. Neon is over here in the last column. 5 plus 1, 2, 3 is 8 in Roman numerals. So that means there should be 8 on our valence orbital. And we do. We have 8 on our valence orbital. So this is correct. Here's silicon. And silicon we have an atomic number of 14. So that's 14 protons, 14 electrons. To find our neutrons, we're going to take our mass of 28. We'll subtract it by 14. And that gives us 14 neutrons. So we'll put 14 in our neutron box. Go over here to our nucleus. We'll put in 14 protons. Adjust our box a little bit. And for our neutrons, we again have 14 of those also. And now let's bring down our electrons. We know the first energy level, or orbital, will fill at 2. We know our second orbital is going to fill at 8. 2 plus 8 is 10. So that leaves me 4 electrons left to deal with. And remember, these electrons have to go out to the third orbital because the second one filled at 8. Okay. Now again, we can check our work. Here's our periodic table. Silicon is right here, and our Roman numeral here is a 5 with a 1 before it. So that's 5 minus 1, which is 4. So we should have 4 valence electrons. And checking out our work, we do. All right, so that looks good. Let's check one more. Last one we're going to check together is chlorine. And chlorine has 17 protons, 17 electrons, 35 is our mass. So let's put that here. And subtracting it by 17, that will give us 18 neutrons. So now we can go over to our nucleus for our atom, and we'll put in 17 protons. And then we'll put in 18 neutrons. And we'll move our electrons down here. We have 2 electrons in the first energy level. We have 8 electrons in the second energy level. 2 plus 8 gives us 10. That leaves us with 7 left. And remember, this third energy level can hold up to 8. So it can hold 7. All right, and one last time, let's check our work. Back on the periodic table, chlorine, since it's number 17, is over here. Remember, they're organized by number of the atomic number, that is. And our Roman numeral here is 5 with 2 1s. So that is 7. We should have 7 valence electrons. And we do have 7 valence electrons. So that means we're right. Okay, so now you're going to check all your work. And after you're done checking all your work, you'll turn it in. And until next time, bye.